Hello friends, in today's question, a uniform disk of mass m and radius r is rolling up a rough inclined plane which makes an angle of 30 degree with the horizontal. If the coefficient of static and kinetic frictions are each equal to mu and the only forces acting are gravitational and frictional, then the magnitude of frictional force acting on disk is and its direction, that is up or down the inclined plane. We have to find out two things. So it is given that a disk is rolling up the rough inclined plane. So let us draw a rough inclined plane, or rather we can say inclined plane, and the angle of inclination is given as 30, and we have a disk. This disk is rolling up the inclined plane with omega angular velocity. So here, suppose this is the center of the disk, so we are going to have mg in the downward direction. This mg can be, this will be over 30, so we have mg sine 30, and this will be mg cos of 30, and we are going to have also a normal acting in this direction. So first of all, let's find out in which direction the friction is going to act, because that will be helpful in writing the equation for, or we can say, accelerated motion. So we are saying that it is moving in upward direction, and its acceleration is given as AC, with acceleration of AC. So what is going to happen? Basically, this is a rough inclined plane, so this acceleration will be also your deceleration. Okay, so this will be your deceleration, not an accelerated motion. So first of all, let's find out what will be the direction of the frictional force. So we assume, let Vc be the velocity of the center of mass, and here AC is nothing but acceleration of the center of mass, or we can say deceleration. So we know the equation that Vc is equal to, let us suppose r is the radius and omega is the angular velocity, is equal to omega. So as it is going up the inclined plane, the Vc is reducing. Okay, we can say for up the inclined plane, we have Vc is decreasing. Therefore, according to, let us suppose, this equation 1, because radius is fixed, you can say therefore omega is also decreasing, and this decrease is so that the equation 1 maintain its sanity. Okay, we can directly say therefore omega is also decreasing. Now in order to decrease this omega, there should be something which is opposing the motion of the, you can say, this angular velocity. Okay. So let me draw this independently here. So it is moving with the angular velocity omega. Okay. So in order to reduce the value of omega, there should be an angular acceleration which is called as alpha, which should be acting in the opposite direction. From here we can say, thus the angular acceleration alpha should be opposite to the angular velocity omega. Now, in order to produce the angular acceleration, there should be some torque acting on this body. So this is the center of mass, and this is our inclined plane, and on this body there are three forces acting. One is mg sine theta, which is the down the inclined plane but through the center of mass. Another one is the normal, that is perpendicular to the inclined plane, which is also through the center of mass. So therefore the normal and mg sine theta, the force which is acting down the inclined plane, will not be producing any torque. So the third force is only that is remaining is the frictional force. That will be producing the required angular acceleration. We can say from here there are three forces acting. First is mg sine theta, and which is through the center of mass, or we can say from here its torque will be equal to 0. Second force is our normal m, which is also line of action is through the center of mass, therefore the torque will be also equal to 0. And finally there is a third force, frictional force Fr, and frictional force is going to act between the point of contact of the surface as well as this disc. So frictional force is going to produce the required torque. Or we can say it will be producing the required acceleration, which is required angular acceleration. So in order to produce the required angular acceleration, the frictional force should be acting up the inclined plane in this direction, that is Fr. So therefore, thus Fr should act up the inclined plane. So we already found out that Fr is acting up the inclined plane, which was asked in the second part, up or down. So we know that it is acting up the inclined plane. Now we can write the equation for the motion for this spherical disc. So angle is given as 30, and we have mg sine 30, and frictional force is acting up the inclined plane, and we said that center of mass is having a deceleration of AC, and its mass is given as m. So therefore we can write the equation as Fr minus mg sine of 30 is equal to m AC, and as it is a decelerated motion we can put here minus. Therefore we can simplify it. It can be written as mg sine of 30 minus Fr is equal to MAC. Let us call this equation number 1. Equation number 2. And as there is a rotation motion, So you can say for rotation of the disk, the torque is equal to I, that is the moment of inertia, multiplied by the angular acceleration, where alpha is the angular acceleration. And we also know that the required torque is being produced by the frictional force. Okay, or we can say the required torque is being produced by the frictional force Fr. So this is our Fr, and the perpendicular distance is given as capital R, and it is producing, this is our angular velocity, and it is producing a angular acceleration alpha in the opposite direction. Therefore we can say that the torque can be also given as, which implies that torque can be also given as the force and the perpendicular distance multiplied by R. So we can equate these two. Let us call this equation as equation number 3, and this is equation number 4. So from equation 3 and 4, equation 3 and 4, we get Fr multiplied by radius is equal to moment of inertia multiplied by angular acceleration. And we know that moment of inertia for the disk is given as half of mr square. You can say, but moment of inertia for disk is given as I, which is equal to half mass of the disk multiplied by r square. And also we know that the angular acceleration will be equal to the product of not product of, but we can say the center of mass acceleration is equal to angular acceleration multiplied by the radius. And we can say that center of mass acceleration will be equal to angular acceleration multiplied by its radius. So we are going to use these two values and substitute in this equation. Therefore we can write it as Fr multiplied by R is equal to I is half mr square, and let me write it here, from alpha will be equal to AC upon R. So this will be coming as AC upon R. So here R square and this R goes. So we get Fr is equal to MAC divided by 2. From here we can say our AC is equal to 2Fr divided by M. So now we are going to substitute the value of acceleration for the center of mass in equation number 2. From equation 2 we get mg sin 30 minus Fr is equal to M multiplied by 2Fr multiplied by M divided by M. M and M cancels out. So here we get as, this will be equal to mg sin 30 is equal to 2Fr plus Fr, which is equal to 3Fr, or we can say our Fr is equal to mg sine theta is 1 by 2, so this becomes mg 2 multiplied by 3. From here we can say our Fr is equal to mg divided by 6. So this is the value of the frictional force acting up the inclined plane. This is the value of frictional force acting up the inclined plane. So this completes the question. Now in this case, another important thing is that if here in the given question it was given that this disk is moving up the inclined plane, so friction will be acting up the inclined plane in order to help in the reduction of this angular velocity, that is omega. Now if this disk is moving down the inclined plane, then also the friction will be acting up the inclined plane. In the, you can say, for the discussion of this, in order to find out rather the direction of the frictional force, the two things are important here. One is the equation which gives the relationship between the center of mass velocity and the angular velocity, that is Vc is equal to r omega. And second is what is the direction of the angular acceleration, because the direction of angular acceleration will be deciding in which the torque will be produced. So here the torque is being produced by frictional force. Okay, so if it is moving in the downward, you can say down the inclined plane, so normally what is going to happen, the center of mass velocity is going to increase continuously, and in order to increase, you can say if Vc is increasing, then this omega is also going to increase. And in order to facilitate the increase in omega, the angular acceleration should be also in the direction of the omega. Therefore, in order to produce the angular acceleration, so in both the cases, whether the disk is moving up the inclined plane or down the inclined plane, the direction of angular acceleration is same. So let me draw it here. So now it is moving down the inclined plane. Okay, so we have a mg sine theta in the downward direction. So now the angular velocity omega is down the inclined plane. So here Vc, which is equal to r omega, where r is the radius, Vc is going to increase. Vc is going to increase as radius is constant. So Vc here is going to increase. So automatically, in order to maintain the sanity of this equation, the omega is also going to increase. So if omega is to increase, the torque will be produced in such a way that the value of angular acceleration facilitate the increase in the angular velocity. So now once again the angular velocity will be also in this direction, so that our angular acceleration will be also in the same direction as that of angular velocity, so that the angular velocity goes on increasing continuously, because our center of mass velocity is also increasing. So from here we can say that the direction of angular acceleration, whether the disk is moving up the inclined plane or down the inclined plane, is same. We can make a comparison. From here we can say the direction of angular acceleration in both the cases is same. Therefore, the frictional force which will be acting will be your up the inclined plane if it is moving down the inclined plane. So this is, we can say, for down the inclined plane. So direction of the friction is same in both the cases. So this completes the entire discussion about in which direction the major part is the frictional force, in which direction it is going to occur. Thank you.